Very good evening. Now we are going to study about the question number 52. Rotation of a rigid body about a fixed axis. The very first thing I would like to tell you here is, if you know how to find the moment of inertia of a rigid body about any given axis, either using parallel axis theorem or perpendicular axis theorem, then only you can find the questions related to rotation of a rigid body about a fixed axis. Because in every question, the moment of inertia will be included, where you have to find the moment of inertia using parallel and perpendicular axis theorem. Now, the very first thing is, what is rotational motion? We need to understand what is the meaning of rotational motion. So when you consider rotational motion, when a rigid body, if it is rotating about a fixed axis, just like a rod hinged at one end and it is able to rotate about its that one end with some angular velocity, then it is called rotational motion. And in rotational motion, one point you have to remember that each and every particle on the body covers same angle. So theta same for every point. That is, omega is same at one instant. At another instant, the value may change. Means from one instant to another instant, the angular velocity may change. But at one instant, all the points on the body must have the same angular velocity. But different bodies will have different linear velocities. If linear distance from the axis of rotation is r, then the linear velocity will become r omega. So linear velocity is different, but angular velocity is same at one instant for every particle, for every point on the body. This is the main thing we need to remember first. Then the thing is, what are the various parameters associated with the rotation of a rigid body? The very first thing is moment of inertia, I, about axis of rotation, about axis of rotation. Then comes the angular momentum. So angular momentum of a rotating body, L equal to I into omega, where I is moment of inertia about axis of rotation and omega is angular velocity. And also the torque acting on the rotating body, torque tau, because torque is the one quantity which causes rotational motion. That is rate of change in angular momentum, or I into d omega by dt, nothing but I alpha, where alpha is nothing but angular acceleration. And many times they will ask the question that if alpha is constant, then for every rotating body, let's say like one disk or sphere rotating with an angular acceleration, then the tangential acceleration of at any point will become its radius into alpha. And then you can apply the equation of motion like omega equal to omega naught plus alpha t, omega square minus omega naught square equal to 2 alpha theta, and theta equal to omega naught t plus half alpha t square. Also, one more thing is, for a rotating body, there is some kinetic energy. That is, rotational kinetic energy is given by half I omega square, or else L square by 2I. So these are the equations based on which we need to, or we can solve the questions related to a rigid body rotating about a fixed axis. Now let's see few questions based on these equations. Like the very first thing is, a uniform disk of mass m and radius r is mounted on an axle supported in frictionless bearings. So one uniform disk of mass m, radius r. Now it is a cord is wrapped around it. So string is wrapped around it, and we applied a steady downward full tension T. That means about the center it will now rotate. So that torque tau equal to tension into R. Because this is the axis of rotation, this is the perpendicular distance, so the torque is TR, that equal to I alpha, where alpha is A by R. So they can ask linear acceleration, they can ask angular acceleration, but here they are asking angular acceleration. So angular acceleration is TR by I. So equal to T tension into R by moment of inertia of the disk is mr square by 2, R cancel. So 2T by mr. So this way, whatever equation I said, but here one more thing, as I said, if you want to solve the question based on the rotational motion, then you need to know how to find torque also. And always you can find the torque about the axis of rotation, because we can find torque about any axis. But if you find torque about axis of rotation, then you can equate it to I alpha, where I is moment of inertia of the body about the axis of rotation. Now in the same question, in the above question, if we attach a mass from the end of cord and allow to fall, then the tangential acceleration of the block. Now the situation is slightly different. See here, now it is fixed. And now one mass is attached. Let's take the mass is M. Now it is coming down. This mass is capital M. So here tension will develop. Now the torque on the disk is again T into R only. But here it is going down with some acceleration, means that is mg minus T equal to ma. Resultant force equal to mass into acceleration. Downward mg will act, upward tension will act. So the resultant force is mg minus T equal to ma, where torque tau equal to I alpha. So TR equal to I into alpha, I can write it as A by R. So that T equal to IA by R square, where I is mr square by 2, just before I said. So A by R square. So tension will become MA by 2. Now I can substitute this value here, so that mg minus MA by 2 equal to MA. Now mg equal to, if you take A common, m plus m by 2. So you can get the equation of acceleration. If you take LCM and solve it, then it will become 2mg by 2m plus capital M. So this is the acceleration of the, tangential acceleration of the block or disk. Now the next question, a phonograph turntable rotating at 78 revolution per minute. So the frequency they have given. So omega will become 2 pi f. That is 2 pi into f is 78 by 60, because it is per minute they have given. And it stops. So initially is this one, and final will become 0 in a time of 30 seconds after the motor is turned off. Then the revolutions made by it in this time are. Now, how can we find this one is omega equal to omega naught plus alpha t. Then alpha value we can get it as minus omega naught by t. So that is minus 2 pi into 78 by 60 into time is 30. Now this is alpha. Now in this time, how many revolutions it made? First you need to find theta. Theta equal to omega square minus omega naught square by 2 alpha. So that theta will become minus omega naught square by 2 alpha. Omega naught is there and 2 alpha is there. So if you substitute, then we will get the theta. Then number of revolutions will become theta by 2 pi. Because for one revolution it will cover 360 degrees, nothing but 2 pi. Then for n revolutions, how many rotations means you have to divide the total angular displacement by 2 pi. So as I said, the question can be asked sometimes based on the equation of motion. So this is the one such kind of question. Now, the next thing is the moment of inertia of the body about a given axis is. So, moment of inertia is 1.2 kg meter square. And initially the body is at rest. In order to produce a kinetic energy, so the rotational kinetic energy half I omega square, that is 1500 joules. An angular acceleration 25 radian per second square must be applied about that axis for a duration. See, from this equation, first you find final omega square, that is 3000 by I. So 3000 by I value is moment of inertia 1.2. Then you will get the omega square value like 0, 3, 1, 0, 0, 0, 0, 3 4s are. So omega will become 100 by 2, nothing but 50. So omega value we got it. With this much of alpha, it should acquire this much of omega within some time. So what is the equation? Omega equal to omega naught plus alpha t. Then t equal to omega by alpha, because omega naught is 0. So if you look at the question here, they are combining rotational kinetic energy and equation of motion together. So like that, they always used to ask the questions based on whatever formulas I said or whatever parameters associated with rotational motion. Now one last and final question. A spherical solid ball of mass 1 kg. What is the mass? 1 kg. And radius 3 centimeter, nothing but 0.03 meter, is rotating about an axis passing through its center with an angular velocity omega equal to 50 radian per second. The kinetic energy of rotation is. They are asking now kinetic energy. So kinetic energy of rotation means half I omega square. Omega given directly. So it is a spherical solid. For a solid sphere about the diameter, the moment of inertia is 2 by 5 mr square. So that here first you need to find moment of inertia 2 by 5, mass is 1 kg, radius is 0.03 whole square. Then you will get the moment of inertia. Then the kinetic energy will become half I omega square, right? So half into I omega square is 50 whole square. So 2 cancel. Now if you solve this equation, then you will get the answer. Like this is 9 into 10 power minus 4. This is 2500 by 5. So 5 5s are 500. So now 4500 into 10 power minus 4. But they have given same thing in terms of ratio. So ratio you try to find it. So just take the ratio. Now, or else I will finish it. Just K rotational is 4500 by 10 power minus 4 you take to down denominator. So 0 0 cancel. 5 9s are, then 5 2s are. So 9 by 20. So this is the answer. So this way you need to find out the questions based on the rotation of a rigid body about a fixed axis. So similar questions I have given as assignment. So please try to solve all the questions. Then you will get the idea like how to solve the questions, right? So thank you all of you. We'll continue in the coming lecture with the next question. Thank you.